What will be tomorrow? It's a question we ask ourselves every evening as we prepare to rest. The uncertainty of the future is a mystery that intrigues us all. We wonder what lies ahead. Will our dreams come true, or will we face hardships? But perhaps the greatest uncertainty that awaits us all is death. Throughout recorded history, no one has escaped it. Eventually, whether through the sun engulfing the earth or a cataclysmic event, our existence will dissolve into atoms scattered through space. We will return to a state of non-existence. However, even in the face of our mortality, the universe will continue its progression. The sun will rise and set on countless planets, seasons will change, and life will persist. The cosmos itself will expand and evolve. While our physical form may be gone, events will unfold as they always have. When we look up at the night sky, we see stars composed of atoms that were once part of living organisms. Space is a realm of possibilities, where the seemingly impossible can happen. Occasionally, anomalies arise that defy our understanding of fixed mathematical forces. The arrangement of stars may seem chaotic, but perhaps it holds a message from another intelligence, one that has eluded us for ages. And what about the countless billions of stars in the universe? If the universe is truly infinite, shouldn't the sky be filled with an infinite number of stars, making it bright? These are questions that have intrigued humanity since ancient times. With modern advancements in space exploration, we are closer than ever to unraveling these mysteries. It's time to peel back the layers of enigma that surround us and embrace the incredible possibilities that the universe holds. Tomorrow may be uncertain, but it is through exploration and understanding that we can uncover the wonders that await us. The James Webb Space Telescope has captured a breathtaking high-resolution portrayal of the legendary pillars of creation, the very birthplace of the stars. First immortalized by NASA's Hubble telescope in 1995, these pillars are nestled within dense clouds of gas and dust. New stars are birthed in these remarkable structures. Though these three-dimensional pillars may resemble unearthly rock formations, they are far more permeable, composed of cool interstellar gas and dust. These celestial columns can appear semi-transparent when illuminated by near-infrared light. Building upon the seminal images captured in 1995, Webb's fresh perspective on the pillars of creation provides researchers with the tools necessary to refine their models of star formation. It offers more accurate counts of nascent stars, as well as the quantities of gas and dust in the region. Scientists are poised to gain a deeper understanding of these enigmatic processes. As we unravel the intricacies of stellar formation, we will begin to discern how stars emerge from these cosmic clouds over a process spanning millions of years. The pillared structures are remnants of stars that have died. The sun will have a similar fate, where its outer layers of gas will escape into space and slowly drift away, creating spectacular and beautiful imagery. With the James Webb Telescope, we are now able to see things in better detail than ever before, not only nearby but also far away. It allows us to explore and understand planetary nebulae, objects that are all over the galaxy, by analyzing their chemical compositions and placement in the expansion model of the universe. Furthermore, the James Webb Space Telescope enables us to observe galaxies and galaxy clusters in great detail. It can capture images of entire galaxies behind galaxy clusters, curved into arc shapes due to the distortion in the fabric of space and time caused by the strong gravitational field of the cluster. These unprecedented images provide insights into the vastness and diversity of the cosmos. The telescope is specifically tuned for infrared light, which allows it to penetrate deep into gas clouds and unveil the birth and formation of stars as well as planetary systems. Similar to human eyes, which have sensors for red, green, and blue light, the telescope captures images in 3 different infrared bands that can be combined to create a color picture. This technology enhances our ability to explore and study celestial objects that are otherwise invisible to the naked eye. Beyond the reach of our naked eye lies a realm of celestial wonders that the James Webb Space Telescope unveils. It serves as a cosmic time machine, revealing distant galaxies, the birth and demise of stars, and the mysteries of the universe. Over a year since its triumphant launch, the telescope continues to provide inspiring images from the depths of space. These visuals shed light on the atmospheres of planets within and beyond our solar system, and unveil the majesty of objects such as Jupiter, capturing its northern and southern auroras, swirling further into the cosmos. And the James Webb Space Telescope may also hold the key to unraveling the enigmas of distant alien worlds, expanding our understanding of the universe and challenging the limits of human comprehension. Through its groundbreaking discoveries, it opens new doors to explore and appreciate the vast beauty and complexity of our cosmic home. A renowned German astronomer breathed new life into the paradox and once again asked the question, why is the night sky dark? Since then, Olber's name has been closely associated with the paradox. During his time, the common belief was that the universe was static, infinitely old, and infinite in size. This time, Olber had a simple solution. If we assume that the universe is infinite, it is logical to deduce that the opaque bodies in it, such as dust and rock, would also be infinite in number. These obstructions would block the light from distant stars, making them appear fainter. The cosmic dust gradually absorbs and blocks the light of stars as it journeys through space. Even today, many people subscribe to this theory, drawing parallels between it and the way clouds obstruct sunlight. However, Olber's compelling solution still does not entirely solve the problem. Any rock or dust would eventually heat up and radiate the absorbed energy. The universe would still contain the same amount of radiation. The dust merely acts as a mediator between the stars and the observer. Ultimately, the energy we detect on Earth would be the same. The solution to the paradox would be revealed another 100 years later, in 1929, when Edwin Hubble peered through his powerful telescope. He hoped to find a collapsing universe, which would prove a finite universe, as Kepler suggested. However, to his shock, he discovered that the universe was not collapsing, but rather that galaxies were moving away from us, as if the space between them was expanding. In fact, the further away a galaxy, the faster it was moving away. The universe appeared to not be falling in on itself or remaining static, but expanding. This raised a new question. If the universe is expanding, what does that mean for the early universe? Cosmologists now believe that the universe was once incredibly small and dense, and that it expanded rapidly in a phenomenon known as cosmic inflation. As the universe expanded, it cooled down and eventually stars and galaxies formed. This discovery ultimately led to the development of the Big Bang theory as we know it today. Scientists estimate that this event occurred approximately 13.8 billion years ago, making it the most accurate model of the birth of our universe. Today, most scientists think that the universe has a finite age and started 13.8 billion years ago. When we look at 13.8 billion-year-old light, it's not because the light from stars hasn't reached us yet. It's because we're seeing a universe before any stars have formed. It's a starless universe that we observe the farther back in time we look, until we reach the edge of the observable universe. This edge is not a physical boundary, but rather the afterglow of the Big Bang, known as the cosmic microwave background. It represents the farthest point in the universe that we can observe from Earth. When we point our telescopes past the earliest stars, we observe this light. It is not starlight, but rather the light left over from the Big Bang, forming a background beyond the stars. However, the Big Bang theory seems to introduce a new problem. It states that the universe was much brighter in the past, especially at the end of the recombination era. All points of the local sky in that era were comparable in brightness to the surface of the sun, due to the high temperature of the universe at that time. Cosmic microwave background should actually be dominating our night skies back on Earth, resulting in a constant need to wear sunglasses all the time to avoid being blinded by the intense brightness of the universe. Thankfully, this is again offset by the fact that the universe is expanding, and the expansion hasn't stopped after the Big Bang. Instead, it has only gotten faster, meaning new space is constantly being created, even faster than the speed of light itself. At first sight, this may seem like a violation of the principle of special relativity, which states that nothing can move through space faster than the speed of light, but in fact it's not. The expansion of space is not caused by objects moving through space, but rather by the stretching of space itself. This stretching is due to the effects of dark energy. A mysterious force that is causing space is measured by a quantity known as the Hubble constant, which expresses the rate at which the universe is expanding. Currently, The best estimates of the Hubble constant suggest that space is expanding at a rate of about 73.3 kilometers per second per megaparsec. This means that the distance between 2 points in space will double in size in about 9.8 billion years. Now, as you may know, light is a wave, and as stars move away from us, their light waves get stretched out. The human eye can only see certain wavelengths of light, and when the wavelengths get too long, we can no longer see them. This is called red shift, as red has the longest wavelength of all the visible colors. For very distant objects, the light waves get stretched so much that they become infrared, and we can no longer see them. So, in a sense, the night sky is lit up. We just can't see it because of our limited human eyeballs. But telescopes can, and that is why we get to see such images. Finally, this is how the solution to the paradox plays out. Because of the finite speed of light and the fact that the universe has a finite age of about 13.8 billion years, this finite age means we can only see stars in galaxies whose light has had enough time to travel to us. The expansion of space-time complicates things even more. In the far-out regions of space where space is expanding faster than the speed of light, the light from those galaxies will never outrun the expansion. No matter what we do or how long we wait, we'll never be able to see light from those galaxies. It will never light up our skies. What we see in the night sky is just a tiny fraction of the whole cosmos. We call this the visible universe, and we cannot, even with the most powerful telescopes, see beyond this horizon. It isn't just a horizon in space, it's a horizon in time. Beyond the edge of our visible universe, the light will never outrun the expansion. Due to this expansion, much further into the future, about 100 billion years from now, imagine we invent a powerful new telescope which will allow us to explore space beyond the galaxy. But as we peek through the telescope, we find nothing but darkness and empty space. The generation of people will have come to understand that they exist within a seemingly endless and almost informationless void. As the age of the cosmos approaches 100 billion, the expansion of the universe will cause all other galaxies to vanish beyond the cosmic light horizon. This means that light from other galaxies will never reach us, and we will be left with a dark and empty view of the universe. Galaxies will no longer be able to reach us. Put another way, galaxies will be pushed aside out of the observable universe and can thus no longer be observed. Today, we lose about 20,000 stars a second. If you think about it, we are rather fortunate to exist at a point in time when we have access to such an abundance of information. Sure, there are a lot of things about the universe that we do not understand, but at least there's hope that one day we will. In the distant future of 100 billion CE, however, they would be so information deprived that when they aimed their equivalent of the Hubble telescope towards a seemingly empty region of space, the returned image would also be empty. Of course, the same is true today. We have no way of knowing what lies beyond the observable universe. But one final question remains. Why are these moon pictures devoid of stars? Surely, with nothing in the way like an atmosphere, we should be able to see some stars in the background. For this, we must learn how color is actually formed. Color is a complex interplay between light and matter. Light is composed of electromagnetic waves of different wavelengths, and when it interacts with an object, some wavelengths are absorbed by the object while others are reflected or transmitted. The colors that we see are a result of the wavelengths of light that are reflected back to our eyes. For example, if an object appears red, it is because the object has absorbed all the other colors of the visible spectrum, such as blue and green, and reflects only red light back to our eyes. Similarly, if an object appears white, it is because it reflects all the colors of the visible spectrum, while an object that appears black absorbs all the colors and reflects none back to our eyes. We are able to see the blue sky on Earth because particles in the atmosphere act as mirrors. The word atmosphere literally means atmos, meaning vapor or atoms, and sphere, meaning globe. During the night, when the sun sets and there is no sky, there is no atmosphere to scatter light, but still, we don't see stars. This is because the light from the sun travels in a straight line without scattering and all the colors stay together. Looking toward the sun, we thus see a brilliant white light. This is what happened with the Apollo astronauts. Every lunar landing took place on the day side of the moon. Even though there was no atmosphere above them, the reflection of the sun's light from the moon's surface made their eyes temporarily blind. The high brightness intensity glare from the sun blinded them and their cameras. Sight of the stars, though, one astronaut reported being able to see some of the brightest stars when he was in the shadow of the lunar module, looking directly up with his protective visor raised. Imagine, though, if astronauts ever landed on the night side of the moon and had their eyes adjusted to near pitch black. They would get a stunning view of the stars if the Earth had no atmosphere. Then, even the Earth's sky would look like the moon's. Currently, taking into account light pollution and limitations of the human eye, we can see roughly 3,000 stars in the night sky and only about 300 stars on a full moon night. This is why some scientists believe it would be a great idea to spend money and time building a large telescope on the night side of the moon. The enigma of the Fermi paradox remains one of the most intriguing mysteries in cosmology, and its solution has provided a deeper understanding of the nature and structure of our universe. Given the millions of billions of Earth-like planets, life elsewhere in the universe without a doubt does exist. In the vastness of the universe, we are not alone. Albert Einstein, according to a recent comprehensive survey by Pew Research Center, 2/3 of all Americans now firmly believe that alien life does indeed exist, and at least 51% have full confidence that UFOs reported by people in the military are likely evidence of intelligent life outside Earth. Considering the significant and groundbreaking advances in astrophysics, scientists today firmly believe that there is a compellingly high probability of discovering extraterrestrial intelligence within the next few decades. Prostek, a distinguished astronomer at the Search for Extraterrestrial Intelligence, SETI, has boldly proclaimed that in a mere couple of decades, we will unequivocally uncover tangible evidence confirming the existence of intelligent life beyond our planet. As humanity casts its ever-expanding net across the vastness of the cosmos, capturing evidence of thousands of worlds, one ancient question haunts us. Is anybody out there? The vast expanse of the cosmos with its many galaxies, stars, and planets makes it very obvious that there is a possibility for life to exist elsewhere. Even if we accept that the origin of life on Earth was a rare occurrence, the immense size of the universe serves as a large blank canvas for the diversity of life to emerge. It is a landscape that might include intelligent beings at all levels of development, ranging from the least advanced to the most evolved. Just imagine yourself alone, weightlessly floating in the vast expanse of space. The silence can be deafening, and the emptiness overwhelming. At first glance, you may believe you are truly isolated, devoid of companionship. However, contemplate the intricate ecosystems thriving inside our bodies, often taken for granted and ignored. Many microbes and tiny organisms may be living on your skin or within your digestive tract, their existence unbeknownst to you. While these organisms may not possess our level of intelligence, their presence serves as a poignant reminder that solitude can often be an illusion. Similarly, the idea that we are alone in the universe may also be a delusion. Unknown to us, life throughout the universe could demonstrate a vast range of intellect that we unconsciously overlook. Intelligence is an extraordinary feature that has profoundly shaped our own existence, and its manifestation can take diverse and fascinating forms throughout the vast expanse of the universe. On distant planets, creatures may have evolved remarkable and exceptional cognitive abilities. Civilizations in the universe can vary in their levels of advancement. Some civilizations may be less advanced than ours, similar to the early stages of human development, with basic communication skills, primitive technologies, and limited understanding of the universe. On the other hand, many advanced civilizations may have surpassed our own, possessing highly evolved intelligence capable of extraordinary feats of knowledge, technology, and interstellar travel. From our limited perspective, their scientific achievements and cultural advancements may appear godlike. The diversity of intelligence in the universe surpasses our wildest imagination, and our self-proclaimed progress may be minuscule on a galactic scale. To categorize civilizations based on their energy consumption and technological advancements, scientists and futurists have proposed the Kardashev scale. This four-tiered system, proposed by Russian astrophysicist Nikolai Kardashev in 1964, measures a civilization's ability to harness and utilize energy. A Type 1 civilization, or a planetary civilization, can harness all the energy available on its home planet, including renewable sources like solar, wind, and geothermal power. They have achieved global unity and can manipulate the resources of their entire planet. A Type 2 civilization, or a stellar civilization, can harness the energy of their host star. They can construct massive structures like desert spheres or distant swarms to capture the energy output of their star. This civilization can tap into the vast resources of their solar system for advanced technologies and interstellar exploration. A Type 3 civilization, or a galactic civilization, can utilize the energy resources of an entire galaxy. They have the ability to move planets, feed black holes with stars, and manipulate the fabric of spacetime. A Type 4 civilization would be capable of creating a universe itself. According to the Kardashev scale, humans haven't yet reached Type 1 civilization status, but we are no longer considered a Type 0 civilization. According to estimations, if our energy consumption increases by 3% yearly, it could take 100 to 200 years to reach Type 1 civilization. Each civilization exhibits distinct methods of communication, which can make it challenging for them to understand each other. Type 1 civilizations, with their planetary scale energy utilization, likely rely on traditional communication methods like radio waves, electromagnetic signals, and optical communication. As civilizations ascend the scale, they may develop more advanced and efficient means of communication, such as gravitational wave communication or quantum entanglement-based systems for Type 2 civilizations. These scales and classifications help us contemplate our future trajectory as a species and better understand our place within the vastness of the universe. Type 3 civilizations capable of intergalactic travel may use methods beyond our current comprehension, such as wormholes or subspace communication. Bridging these gaps is crucial for establishing effective channels of understanding between civilizations. In our early endeavors as a Type 0 to 1 civilization, we sent physical messages into outer space to communicate our presence and curiosity. Examples include the Pioneer plaques and Voyager golden records affixed to spacecraft sent beyond our solar system. These messages symbolize our desire for contact but have limitations in establishing meaningful communication. The vastness of space makes it highly unlikely for extraterrestrial civilizations to randomly come across these physical messages. Additionally, these messages are unidirectional and cannot receive or transmit responses, hindering a meaningful dialogue. The immense differences of celestial objects mean that the journey of physical messages can take hundreds or even thousands of years, making timely interaction and mutual learning impractical. After 60 years of searching for extraterrestrial intelligence, we remain unheard. SETI, the main institution devoted to this search, has not detected any artificial signals. The abbreviation for the Search for Extraterrestrial Intelligence, SETI, is a project that relies on the use of radio telescopes. These telescopes receive radio waves, as we cannot physically travel to space to search for intelligent life. Instead, we search for radio signals. Scientists use radio telescopes located around the world to scan the skies for narrowband signals that stand out against the background noise. Scientists hope to listen to the whispers of the universe, similar to tuning your FM radio to find a specific frequency. Usually, scientists search for signals in the water-hole frequency range, which includes the hydrogen line and the hydroxyl line. These frequencies are considered favorable for communication due to their proximity in the electromagnetic spectrum to the natural radio emissions of hydrogen and hydroxyl, which are abundant in the universe. However, there is a significant hurdle in our path: the language barrier. Language is the foundation of human communication, allowing us to convey ideas, emotions, and knowledge. But when it comes to extraterrestrial beings, understanding their language becomes a complex task. How do we decipher the codes of an alien civilization? What forms of communication would they employ? These questions lie at the heart of the language barrier in SETI. Decoding ancient languages on Earth often relies on context and comparisons to other languages. But when faced with the challenge of decoding an alien language transmission, these familiar tools are absent. There is no context available, and there are no similar languages to draw comparisons from. Moreover, Assuming aliens use a verbal language is a significant assumption, as numerous species on Earth communicate without words. For example, cuttlefish and chameleons communicate through body color languages, while ants and honeybees use pheromones to communicate within their species. Even if we were to understand the letters and words of an alien language, it does not guarantee that we would understand their meaning. Language for us is based on cultures and requires a common frame of reference. If you were to say, "I'm going on a hike and capturing some stunning views with my drone," to a squirrel in the park, it would have no way of comprehending your statement. You would need to explain the concepts of hiking, capturing, stunning views, drones, technology, flying, cameras, video recording, and even visual appreciation, all of which are intuitive to modern humans. In the event of an encounter with an advanced alien civilization capable of interstellar travel, it is crucial for us to demonstrate a basic understanding of the universe to establish meaningful communication. Mathematics, as far as our knowledge extends, is considered a universal language. It transcends cultural and linguistic barriers, allowing for communication even when direct language comprehension is difficult. Harnessing the power of mathematical concepts, we may unlock a means of communication with alien civilizations. Foundational concepts such as addition, subtraction, multiplication, and division are universally applicable, serving as a framework for numerical communication regardless of the location in the universe. The fundamental truth remains that 2 plus 2 equals 4, and the ratio of a circle's circumference to its diameter is approximately 3.141592 and so on. While the specific numerical labels may differ across civilizations, the underlying concepts remain unchanged. One approach to mathematical communication with aliens is through the use of bits in digital communication. A bit is the smallest unit of information represented by a binary value of 0 or 1. By using a series of bits, we can encode and transmit messages. For instance, we can allocate a unique series of bits to each letter of the alphabet, creating a binary code that represents written communication. Thus, we could introduce the concept that 1 bit signifies the letter A, 2 bits represent the letter B, and so forth. This binary code could serve as a foundation for communication, allowing us to transmit longer written messages that could be understood by an intelligent alien civilization. Therefore, we could show the aliens our understanding of math. Though it would be a tremendous intellectual challenge, composing a message that can be understood by aliens will be extremely difficult, and conversation may almost be impossible. Extraterrestrials could be millions of years more advanced than we are. These hypothetical life forms may have long abandoned their biological bodies to exist solely within a computerized body. In this scenario, they may have relinquished their individual consciousness to merge into a global digital network of minds, giving rise to a vast collective consciousness. Due to this huge intelligence gap and the absolute cluelessness about the possible aims of an extraterrestrial intelligence, some scientists have voiced their misgivings about announcing our existence to extraterrestrials. However, even if there were potential risks or challenges in communicating with alien civilizations, the pursuit of understanding and discovering new forms of life and intelligence is an inherent aspect of human curiosity. Even if another civilization can come to Earth, it's already too late to conceal our existence. Any civilization with the ability to travel between the stars can already pick up our radio and TV signals that are leaking off into space. There's no added danger of transmitting signals through active SETI, search for extraterrestrial intelligence, considering the information we now possess. It is plausible that a first contact could occur in the near future, and it's also possible that some civilization has already listened to our messages, but hasn't responded because they prefer it that way. These processes, known as active SETI or MET, messaging extraterrestrial intelligence, involve intentionally transmitting messages or signals from Earth into space. By taking a proactive role in initiating communication, scientists hope to attract the attention of intelligent beings that may be listening or capable of receiving the transmitted signals. This shift from passive observation to active engagement reflects a growing belief that humanity should actively participate in the quest to establish contact with other civilizations. Nevertheless, how is it possible that given the huge possibility of other civilizations, we haven't yet received any evidence of their existence? This question, known as the Fermi paradox, was first raised by legendary physicist Enrico Fermi. Speaking to his colleagues during lunchtime, he raised a seemingly simple question. So, where is everybody? Why haven't we seen any proof of alien civilizations yet, given how likely it is that they exist? Perhaps at the end of the day, maybe they simply don't bother to communicate with us. When you consider our civilization's level of development, the answer is pretty obvious. Why would they? The logistics required for interstellar travel are only available to civilizations that have reached at least Type 2 on the Kardashev scale, and in their eyes, we're not worth it. What person in their right mind would try to communicate with ants? How would an ant be able to recognize that someone's trying to communicate with it? After all, in terms of our development and technological advancement compared to them, we're akin to highly developed ants that have taken over an entire planet. This is called the zoo hypothesis, where extraterrestrials may have chosen not to initiate contact or reveal their presence for various reasons, such as respecting our development, avoiding potential conflicts or cultural clashes, or simply having no interest in communicating with less advanced civilizations. Another explanation for the Fermi paradox is that we may have already received those signals, but we haven't realized it. We haven't perceived the signals or have been able to understand or decode them. In this case, some strange signals from outer space have been received, and their origins are now being investigated, posing serious questions for scientists. The most famous signal that has been detected came in 1977 at Ohio State University's Big Ear radio telescope. While listening for signals from another civilization, a strong message spread out over a frequency was observed. During his work on the night shift on July 15, 1977, Jerry R. Amen, a professor at Ohio State University and a volunteer for this SETI project, observed the peculiar transcription of the radio signal made by a computer on a section of paper feed. Later, it was confirmed that this signal was the most intense anomalous signal detected up to that point by a radio telescope. The signal of unknown origin had a duration of 72 seconds and reached an intensity 30 times higher than conventional signals. Come from the constellation of Sagittarius. The computer processed the received signals into a series of alphanumeric characters, producing the sequence 6E5. In fact, it was so astounding that when the technician looked at the printout the next morning, he wrote "wow" in the margin, and that has become known as the wow signal, which has kept the international scientific community on edge until today. Eamon and his team conducted an exhaustive examination of the signal and eventually ruled out any interference coming from Earth. Over the following month, the operators of the radio telescope attempted to relocate the signal, but they were unsuccessful. Astronomers have looked at the same part of the sky many times since then, hoping to find the wow signal again, but they have never been able to replicate it. The key to progress in SETI is to find a signal that is as remarkable as the wow signal, but not just once. It needs to be found repeatedly. Today, the origin of that signal is still under investigation. There are hundreds of billions of stars in our galaxy alone, and there are billions of galaxies in the universe. If life appears on only a minuscule fraction of those planets, then life and their enthusiasm for knowledge and exploration have started the search for intelligent life, with the hope of sooner or later finding it or being found by it. The first contact may not happen within our lifetimes, but whenever that occurs, it will be a turning point in the life of the human species. What will happen from then on? What will occur when we receive a signal and it is confirmed as extraterrestrial? How would that affect our lives, our priorities, our conception of the world, and our own identity? Will mankind be prepared? On November 13, 2004, scientists at NASA were using the Hubble Space Telescope to capture images of a previously unexplored and empty region of the sky. With low and minimal expectations, they did not expect a lot in return, just a dark and empty image, and the scientists could call it a day. However, the telescope returned an image of a planet located just 25 light-years away from us, orbiting a star double the size of our Sun. This was the first time a planet was directly observed through a telescope. Against their expectations, the scientists could not wrap their heads around what had just transpired. Never before in history had a planet been found based on direct observation. In fact, the person who discovered it said he nearly had a heart attack. The image that was captured reveals a star at the center, now formally known as Fomalhaut, which is surrounded by huge swirling clouds of dust and debris, encircled by a continuous round asteroid belt. And among these millions of rocks dotting the image lies a planet surrounded by real mystery. Once named Dagon, this planet, clearly visible in the photo, never truly existed. Seen right now is nothing but the phantom of a planet that never came into being. Astronomy has not yet encountered anything like this before. What could it be? A glitch in the matrix? Could someone else be involved? Or could a whole planet disappear too? In 2004, when NASA first discovered Dagon, something seemed off right from the start. It was behaving strangely, defying the odds. According to what we knew, planets like Dagon, 2 to 3 times the size of Jupiter, shouldn't have been able to form around such a young star like Fomalhaut, which is just 400 million years old. For comparison, our Sun is about 4.6 billion years old. Additionally, since its star is surrounded by a protoplanetary disk of gas, ice, and dust, the first planets to appear around it should be superheated and glow in the infrared. However, Dagon emitted ultraviolet light instead. Moreover, the planet was incredibly radiant, shining with an intensity rarely observed on exoplanets. Its remarkable brightness raised numerous questions among scientists. For the most part, scientists thought maybe it was the presence of an expansive ring system akin to Saturn, which could enhance its reflective properties, thus intensifying its luminosity by capturing and redirecting more sunlight. And what's more, research showed that Dagon behaved in a very strange manner. Though it's unknown how much time it takes to make one trip around Fomalhaut, according to estimates, the speed of the planet just kept on increasing while it cruised on its 1,700-year orbit around its star. During those early years, it seemed obvious that Dagon was acting in a way that a legitimate planet should not. Its unusual movements and unexplained appearance never stopped puzzling the research team. However, due to various constraints and shifting priorities in the scientific community, resources were redirected to other projects, and the tracking of Dagon unfortunately came to a halt. Nevertheless, the Hubble telescope continued capturing images of Dagon over the years. This hiatus, lasting a decade, came to a stop in 2020 when NASA made the decision to delve back into their archives, and what they found left them astonished. The planet had mysteriously vanished into thin air back in 2014. Although in previous years, the object was consistently registered by the Hubble Space Telescope. Starting in 2006, the planet started increasing in size and becoming more dim until it decided to finish scientists off and just disappear, as if it had never existed, leaving everyone perplexed and searching for answers. It looked like the planet didn't just vanish, but dissipated. Scientists had reached an impasse. All of these events went against everything the scientists knew about exoplanets. Until now, the researchers had to practically review the data again to come to a new radical conclusion that the planet Dagon never existed and to substitute wandering through the cosmos, rather than a permanent resident of its star system. This theory suggests that Dagon was not a permanent resident of its star system, but somehow got detached from its parent star, venturing into the Fomalhaut system, captivating astronomers who clicked its presence in the nick of time and eventually departed the Fomalhaut system. The idea of a planet on the move, untethered from a star's gravitational pull, added a layer of intrigue to the mystery. What cosmic forces guided Dagon on its trajectory? Did it also encounter other star systems along its path, engaging in gravitational dances that reshaped its course? Delve deeper into the intricate dynamics of the Fomalhaut star system, a more plausible explanation emerged. Extensive analysis of the system's gravitational interactions and the presence of a massive debris disk revealed that the likelihood of Dagon being an elusive wanderer was slim. The complex gravitational forces exerted by the stars and the constraints imposed by the surrounding debris disk would have significantly hindered the planet's ability to roam freely without being influenced or detected. If Dagon had indeed been a rogue planet traversing the system, it would have left discernible traces of its passage in the surrounding debris disk, much like the trails formed by the wings of an airplane on clouds. Just as these trails offer evidence of the airplane's presence and movement, astronomers expected to observe distinctive disturbances or patterns within the debris disk caused by the interaction with Dagon. Yet, despite meticulous examinations, no significant indications of such disturbances have been found. The absence of discernible breadcrumbs, akin to the trails formed by airplane wings and clouds, raises doubts about the hypothesis of Dagon as a wandering planet. Scientific scrutiny, guided by evidence-based reasoning, compelled scientists to explore alternative explanations for the vanishing of planet Dagon. A new and the most plausible theory proposed by the scientists suggests that the object originally interpreted as an exoplanet was a slowly dissipating dust cloud. This cloud formed as a result of a massive collision between two asteroids or planet fetuses, each about 200 kilometers or 125 miles in size. This discovery is even more amazing because a collision between two small celestial bodies is incredibly rare. The ability of scientists to capture the image of the collision was an incredible stroke of luck. In the vastness of space, where distances are unimaginably immense, such collisions between celestial objects are estimated to occur once every 200,000 years or so. The collision must have happened back in 2004 when the Hubble telescope was surveying the area around Fallout. Coincidence number 1. As time went by, the dust began to spread, which explains the increase of the object's size and the lowering brightness. Coincidence number 2. And the dust cloud that formed in the collision explained the eccentric orbit. Coincidence number 3. So, a string of incredible coincidences confused the astronomers and created a beautiful legend about a strange and unpredictable planet Dagon. It does not look like a planet or move like a planet, does not revolve around a host star or an elliptical orbit like a planet. Instead, it moves along a runaway trajectory that eventually takes it far away from the star. It was an extraordinary occurrence that they were able to witness and document this event, defying astronomical odds. After connecting all the dots and examining the accumulated evidence, scientists ultimately concluded that Dagon, once considered an exoplanet, should no longer hold that status. Just 1 micrometer in size, surpassing the scale of any known planet, this massive yet tiny dust particle cloud has rendered Dagon invisible to the Hubble telescope. The disappearance of planet Dagon provides a rare opportunity to study planetary collisions, unraveling their dynamics and aftermath. Computer simulations and observations have revealed that powerful space collisions can even transform celestial objects into expansive clouds of fine particles. The similarities between the Dagon collision and our solar system's early stages are also significant. By analyzing the debris and its composition, scientists gain insights into the processes that shaped our cosmic neighborhood billions of years ago. The scattered particles in the Fomalhaut star system offer valuable information about the building blocks of planets and the conditions that facilitated their formation. This knowledge enhances our understanding of planetary systems and fuels our exploration. An object in space vanished before scientists' eyes. A similar tale occurred with exoplanet Alpha Centauri in 2012. Astronomers at the European Southern Observatory detected fluctuations in the radial velocity of a star using the precise HAR-PS spectrograph. These fluctuations could only be caused by a planet's gravitational pull. This breakthrough method, known as Doppler spectroscopy, is highly reliable, with only a 0.1 margin of error. With just 1 miss among 1,000 hits, it ignited a profound sensation within the scientific community. This fervor was further heightened by the fact that Alpha Centauri b, situated a mere 4.5 light-years away from our solar system, stood as the closest exoplanet in proximity. Astronomers revealed that this planet orbited its star too closely, outside the habitable zone, with surface temperatures reaching around 1200 degrees Celsius, nearly 3 times hotter than Venus. Scholars eagerly sought to calculate its orbit parameters, but before they could do so, Alpha Centauri b vanished into thin air. 3 years after its 2015 discovery, reanalyzing the data, experts at the University of Oxford discovered that the velocity fluctuations initially seen as proof of the exoplanet's existence were, in fact, just calculation errors. However, it's downright bizarre when, instead of a planet, a star mysteriously vanishes. After being diligently studied for a solid 10 years from 2001 to 2011, Numerous astronomical teams lock their gaze on a luminous blue variable star nestled within a dwarf galaxy called PHL 293b, situated 75 million light-years away. Their aim was to learn more about how these types of stars end their lives. These luminous blue variables have a distinct and unmistakable light signature. They are colossal supergent or hypergent stars, teetering on the precipice of their life cycles, bursting with brightness and plagued by instability. They undergo violent outbursts and eruptions that cause drastic fluctuations in both their radiance and spectral characteristics. During these dramatic episodes, their luminosity can even double in intensity. Staying true to the nature of these luminous blue variables, our mystery star, under scrutiny in its advanced life stages, shone brightly with its radiant luminosity. However, when scientists directed the powerful Very Large Telescope of the European Southern Observatory toward the PHL 293b galaxy in 2019, the star had mysteriously vanished. A meticulous analysis of data collected between 2011 and 2016 revealed an unsettling truth. It had ceased to be visible after 2011. Firstly, it's plausible that the star dimmed and became veiled within a shroud of ejected material, resembling the ambiguous dust cloud that may have concealed our very own Milky Way's red giant star, Betelgeuse, a couple of years ago. Under this scenario, the star might have continued its eruptions, concealed behind this thick fog of gas and dust, rendering it invisible to our eyes. Infrared observations conducted in 2009 hinted that this obscuring cloud would need to be chillingly cold to remain undetected and shroud the star effectively. Alternatively, based on certain models, it is proposed that the luminous blue variable star, rather than undergoing the anticipated supernova phase, skipped this explosive spectacle altogether and transitioned into a slow-spinning black hole. This notion gained support from recent research on a colossal red star that rapidly brightened before abruptly vanishing in a galaxy located 22 million light-years away, published back in 2017. The researchers hypothesized that this star had experienced a failed supernova before its ultimate collapse. Building on these findings, the team postulates that the luminous blue variable star in PH 293b was also in an eruptive state between 2001 and 2011, after which it vanished either by bypassing the supernova stage entirely or faltering in its attempt to initiate one. In most cases, stars nearing their end typically culminate in a spectacular supernova before transforming into either a black hole or a neutron star. This explosive phase is hard to miss, often persisting for several years. Astronomers would have undoubtedly caught a glimpse of such an explosion if it had occurred. This puzzling situation challenges our understanding of stellar life and death, forcing us to reconsider the enigma of the missing star presently remains unsolved, leaving astronomers eager for future measurements across various wavelengths to unlock the secrets shrouded within this cosmic riddle. In 1972, an extraordinary spacecraft named Pioneer 10 embarked on a thrilling mission to explore the vastness of the asteroid belt and the colossal gas giants that dominate our solar system's outer reaches. Traveling at a speed of 32,000 miles per hour or 51,500 kilometers per hour, Pioneer 10 soared away from Earth on a transformative journey that would eventually pave the way for future endeavors such as the Voyager probes. While the Pioneer mission ultimately achieved remarkable success, it was not without its fair share of challenges and obstacles. Little did the world know, the probe had carried with it a hidden problem, a riddle that would puzzle even the brightest minds in astrophysics for decades. Plagued with a number of malfunctions, Pioneer 10 has sometimes been referred to as the luckiest spacecraft ever launched. Basic and fundamental theories in the early 1980s. While the probe was still in contact, scientists had noticed something quite intriguing. The probe was both slowing down and veering off course, as if an unknown force in space was putting the brakes on and tugging it back toward the sun. Despite conducting extensive research and tirelessly analyzing data for about 15 years, the solution to this puzzle remained elusive. Instead, the slowdown came to an abrupt end, leaving behind one of the greatest mysteries in the history of spaceflight. Even today, the Flyby anomaly continues to confound our understanding of spaceflight, causing some spacecraft to deviate ever so slightly from their intended trajectories. It remains a glitch that tests our knowledge and leaves us searching for answers. Launched back in 1972, Pioneer 10 became NASA's pioneering mission to the outer planets. The probe earned its moniker from the valiant pioneers who settled the western United States because, just like those explorers of old, Pioneer 10 aimed to boldly go where no spacecraft had gone before. Pioneer 10 achieved remarkable triumphs, marking several firsts in our space exploration. It was the first to venture beyond Mars, traverse the asteroid belt, and reach the mighty gas giant Jupiter. Pioneer 10 also made history as the first spacecraft to utilize an all-nuclear power supply and follow a trajectory that would lead it beyond the boundaries of our solar system. Originally intended for a modest 21-month mission, Pioneer 10 far exceeded expectations, defying the odds and persevering for over 30 years. However, in January 2003, after its long and distant journey, the venerable probe bid its final farewell, transmitting its last signal back to Earth. Today, Pioneer 10 continues its cosmic voyage, a solitary vessel drifting like a ghost ship through the frigid expanse of space over 11 billion miles away, in the opposite direction of the sun's motion through the galaxy. Twin Pioneer 11 took off into the great unknown a year later in 1973. Following in the footsteps of its predecessor, it became the second probe to successfully pass Mars, navigate the main asteroid belt, and reach the majestic planet Jupiter. Finally, Pioneer 11 etched its name in history by becoming the first spacecraft to fly by Saturn. Unlike its twin, however, after leaving Saturn, Pioneer 11 headed out of the solar system in the opposite direction, at an angle of 90 degrees to Pioneer 10. Its destination, the center of the galaxy, present within the constellation of Sagittarius. In 1995, NASA received the last signal from Pioneer 11, marking the end of its communication. It silently vanished into the depths of space, leaving behind a legacy of exploration. But unknown to many, both of them had left behind a puzzle that would baffle even the most seasoned physicists for decades. Just like many confusing puzzles, this one began with a subtle hint of inconsistency. Shortly after Pioneer 10 and 11 ventured beyond the orbits of Jupiter and Saturn, their navigators made a surprising discovery. Both spacecraft appeared to be experiencing a greater slowdown than what the navigators had initially anticipated. It was as if an unknown experienced a deceleration that defied explanation. Despite being aware of the natural deceleration caused by the sun's gravitational pull, scientists discovered an excessive slowdown. The deceleration rate was incredibly small, only 1/10,000,000th of Earth's gravitational acceleration. John Anderson and his colleagues calculated that the spacecraft had a deceleration rate of about 300 inches per day. While this might seem insignificant, it had significant implications. The spacecraft ended up being thousands of kilometers closer to Earth each year than intended, deviating from their expected positions. Similar trajectory issues were faced by the Galileo spacecraft, launched in 1989, and the Ulysses spacecraft, launched in 1990. Scientists explored various possibilities to explain these decelerations, from gas leaks to the expansion of the universe. However, no conclusive answer was found, leading to the hypothesis that it could be attributed to new physics contradicting Einstein's general theory of relativity. In 2004, Slava Turishev, a physicist at NASA's Jet Propulsion Laboratory, contemplated building a new probe to investigate the Pioneer anomaly. However, this plan remained on the drawing board due to constraints. Despite the setbacks, Slava and his team searched for data and collected over 43 gigabytes of information. The answer to the anomaly was found in the structure of the Pioneer probe. NASA engineers had to spin the probes to ensure stability and maintain communication with Earth. This spinning motion caused the deceleration. Overall, the anomaly persisted without a conclusive explanation, raising the possibility of undiscovered phenomena that could reshape our understanding of the universe. Thermal radiation emitted by the spacecraft had two sources positioned on the leading side of the spacecraft. The first source was the electric box, and the second was the radioactive material responsible for power generation. Both of these sources emitted heat in the direction of the spacecraft's motion through space. This emission of heat created a small photon pressure in the opposite direction of the spacecraft's motion, resulting in the observed deceleration. It's the same principle that operates in a solar sail, where the spacecraft is propelled forward as photons from the sun collide with it. Now here's the interesting part. The slowdown of the Pioneer probes came to a sudden halt when the radioactive material was completely used up. With the wealth of new data at their disposal, Slava and his colleagues were able to calculate the amount of heat generated by the electrical subsystems and the decay of plutonium in the Pioneer power sources. These calculations perfectly matched the anomalous acceleration observed on both Pioneers. But other spacecraft, like Galileo and Rosetta, took into account the thermal recoil, yet they still encountered deviations in their paths. When the Galileo spacecraft was on its way to Jupiter, something peculiar happened during a gravity assist maneuver where it flew past Earth. Scientists noticed an unexpected increase in the spacecraft's speed. There was a discrepancy, a difference in speed relative to Earth, with an unanticipated boost of about 4 millimeters per second. This effect, known as the flyby anomaly, has affected almost every spacecraft out there. The flyby anomaly reveals something quite intriguing. Some spacecraft actually gain more speed when traveling to or away from Earth than what scientists initially predicted, and so far, no convincing explanation has been found. The flyby anomaly, observed during multiple spacecraft missions, continues to intrigue the scientific community. During the Near Shoemaker mission in 1998, scientists noted a significant increase in velocity during the Earth flyby to study asteroid 433 Eros. The anomaly has prompted various theories to explain its occurrence. One suggests that the Earth's shape and composition, creating uneven gravitational forces, could affect spacecraft trajectories. However, this theory is challenged by the fact that other spacecraft orbit Earth without experiencing the anomaly. Another proposal focuses on the Moon's configuration, tidal conditions, or even the presence of atmospheric particles during flybys as potential contributors to the anomaly. Additionally, solar winds and relativistic effects, such as distortions in spacetime caused by Earth's rotation, are also considered. To solve this mystery, scientists are conducting experiments and analyzing data. One potential solution involves the launch of the STEP spacecraft by 2024. By following an orbit that encounters the locations of observed anomalies, Astounding aims to provide precise measurements and valuable insights into this phenomenon.